Good morning to the students. I'm going to take today the engineering mechanics. Being you are the first year students, the engineering mechanics, you may not be aware, but you know the force. So the application of the force which is acting on the body, that study, what you call it is the engineering mechanics. The study of force acting on the body when it is a rest or it is in the motion, what you call it is a mechanics. So the force, the force is nothing but a amount of energy which is required to pull or push the body. That is quantified in terms of the force. So that force, how it is acting on the body, and then what is the acting on the force on the body, how the body is reacting. The body is maybe in a rest condition, or it may be in the moving condition, motion. So, and also the engineering mechanics, it will be broadly classified into one is solid mechanics and then fluid mechanics. So solid mechanics will be deals with the rigid bodies. Fluid mechanics, which is deals with the fluids, the behavior of the fluids under the external force which is acting on the fluids. The solid mechanics, or what you call as the engineering mechanics, which is deals with the force which is acting on the body. So this mechanics mainly it is acting on the particle. That particle may be again classified into it is a rigid body, or it is a non-rigid body, or what you call it is a flexible body. So this rigid body and then flexible body, the force acting on this body will be, so the particle what you can say having a rigid body and then non-rigid bodies. So the particle, which is nothing but what you can say a body with mass and without dimension. So that means not dimension means you can't quantify it with the dimension. You can say having the mass, maybe a irregular shape or maybe a regular shape. The rigid body that doesn't deform under the action of force. So it is so rigid. For example, taking the stone, it is what you call it is a rigid body. Non-rigid bodies, a body which can be deformed. Small amount of deformation will be happen when the application of the force. So the rigid body, the example what I can say is the hockey ball. So when you are striking that hockey ball, and then also the cricket ball, which is struck by the bat, so the ball is not getting a damage, or it is not undergoing any deformation. So that is the ball here act as a rigid body. It is a rigid body with the application of the either maybe a hockey bat or it may be a cricket bat. The ball is not getting a deformation. So the ball here, what you can say, it is a rigid body. But the ball is acted upon a quantified amount of force. Even though the force is striking on by the bat on the ball is not getting a deformation. So what you call it is a rigid body. Non-rigid body, the example is a football. So the football, when you are striking the football, even though it is filled with high pressure air inside the ball, there may be a small amount of deformation is taking place. So what you call that is a non-rigid bodies, or what you call it is a flexible body. It is a flexible body. So the rigid body, again, this class we can categorized into statics and dynamics. Statics, the body which is under rest, but the force is acting on the body. What you call it is a static condition. Dynamic, the body is moving. The body is under the motion, and then there is external forces acting on the body. Then you may call it as a dynamics. So this dynamics again is classified into kinetics and then kinematics. So the static force, the example you can give, you may be know some competition, they may be conducted during the festival season. That means what you call lemon on the spoon. lemon on the spoon. So you have to keep the spoon on your teeth and then keeping the lemon on the other side. So when you are standing, so even though the weight of the lemon is small, but you can experience the force which is acting on your teeth. So this is what you call it is a static. The example is the static. And also when you are sitting on the chair, your load will be equally distributed to all your four legs. That is also static. And also standing, when you are standing on the platform, so the total your weight is acting on that, but what you say, it is a static condition. Same this dynamic condition, same this the game where the people are starts to moving with the spoon and then lemon. So you have to very careful that the lemon should not fall down. So you have to keep your teeth and then mouth equilibrium condition, keeping the same position and then keep on walking and then complete the task. That means complete the distance what you have to cover. That is what you call it is a dynamic. That is the example. And also what you say, all the moving bodies, even the vehicle is moving, it is a dynamic. So the dynamics, that is a kinematics. That is means that the vehicle is moving with some velocity, speed. When the vehicle moving with some speed and then hitting the object, then the kinematic problem will be kinematic problem will be converted into kinetics. That means there is a external force which is acting on the body. So with the body is moving without any external force acting on the body with a constant velocity acceleration, then you say it is a kinematics. So when the body is acted upon by the external force on the moving body, that may create some deformation, then you may call it as a kinematics. So the kinetics and kinematics you may know. And also what you say, the kinematics, that can be also you can give the example of the 4-bar link mechanism. 4-bar link mechanism. There is a motor which is having the input link, whereas there is a connecting rod, there is output, so which will be having the oscillatory motion. That is what you call is a kinematic example for this. And also the kinetics, when the body is hitting on the body, when the body is hitting on the moving body, then the kinematic problem or the system will be converted into kinetic problem. And you know that the force, which will be the vector quantity, it will be having both magnitude and velocity, acceleration, all it will be vector. Scalar, so the example is mass time velocity density, so it will be a defined one. So what you call the volume, it is a scalar, it will be having only a magnitude, not direction. Vector quantity, it will be having both direction and magnitude. So the force acting on the body, so you can start with a single force. The body which is acting on the body with a single force. So the body should not get a deformation, or it should not deviate from the original position. It should be in the equilibrium. So what you have to do, apply the force equal and opposite to the direction of the force which is acting on the body. That is for a single force which is acting on the body. Suppose the body is subjected to two forces. The body is subjected to two forces. The body, two forces acting on the body. So you are not supposed to undergo any deformation, or you are not allowing the body to go deformation or in a equilibrium condition. So you have to apply equal and opposite force to that two forces. For that, what you can do, you can use the parallelogram law of forces. So the two force system that can be replaced by a single force. That single force system based on the parallelogram law of forces. What is parallelogram law of forces? Suppose if you are the body is subjected to two forces. So if you are replacing the two forces on two sides of the parallelogram, so keep the one force on one side of the parallelogram, keep another force on the next side of the parallelogram. So the diagonal will be the resultant. The resultant is nothing but it is a diagonal. So that is giving the resultant force. That resultant force opposite to the direction will be the reaction force that will keep the object in the equilibrium condition. That means the parallelogram law of forces state that if you are replacing the two force system represented on two sides of the parallelogram, the resultant will be the diagonal of the parallelogram. So that resultant force acting on the diagonal of the parallelogram, opposite to that one is the resultant force will be having on the system, bringing it to the equilibrium condition. And then next, three force system. So when the object is subjected to three forces, suppose the object is acted upon by three forces. So this three forces will be having the magnitude and direction that will deform the body. But the aim is the body should not get deformation. So it should be equilibrium condition. So the three force system, how that can be replaced? You can replace it by, you can go by Lami's theorem, or you can go by Polygon law of forces. If more than two forces acting on the system, you can resolve the force by more than two forces, you can resolve by Polygon law of forces. What is the Polygon law of forces? Suppose if you are representing all the forces to the sides of the polygon, the closing side will be nothing but the resultant force. The closing side of the polygon is the giving the resultant force. That resultant force, if you are applying opposite direction of that force, that system keeping in a equilibrium condition. So you can do by the Polygon law of forces, you can get the solution by analytical method and then graphical method. Analytical method, you can go by applying the formula, and then graphical method, you have to draw the polygon, and then the open side will be the polygon, closing that side will be giving the resultant force. And then the direction, what is the analytical method? Resolve the forces into horizontal component and vertical component, and then sum up all the horizontal force component, sum up all vertical force component. So it is nothing but the resultant force is equal to square root of sum of all vertical forces square plus sum of all horizontal forces square. If you want to find out the direction of that resultant force, tan theta is equal to sum of all vertical force divided by sum of all horizontal forces. And then, so more than two forces acting, you can go by Polygon law of forces, or you can go by analytical method. Dear students, I am stopping up to this question, and then I will continue the next class. Okay, thank you.